Hello seniors, today we're going to continue with electronic assignment number 16, which is about extrema and optimization problems. We have seen the first part already, in which we saw a second technique in order to determine whether a function has either a maximum or minimum point at a critical number, right? At a given critical number, which is found by setting the first derivative to 0, right? So we have seen these two problems together, and today we're going to see the following. It says, we have been finding relative or local extrema of functions. We can also find absolute or global extrema of a function, okay? So we've seen relative up to now, but today we're going to see the concept of absolute, or also known as global extrema of a function. And it says, absolute extrema are the greatest and least values of the function over its entire domain. Absolute extrema occurs either at the relative extrema or endpoint of a function. So there are two places where the absolute extrema may occur. Either at a relative extrema, which is what we were studying before, or endpoints of a function, which are given by the domain of the function. We're going to see this in the problem below in a while. So it says the relative extrema of a function are the minimum and maximum values of the function on an interval near the critical point. Relative extrema never occur at the endpoint of a function. Okay? So basically the endpoint of a function, if you're asking yourselves what are endpoints, endpoint of a function are basically points where the domain ends. For example, for this function over here, we have from -1 to 2, and this means that, for example, -1 is right here in x, and 2 is over here for this point over here. So that means that the function is graphed from -1 to 2 in x. And these 2 points, a and d, are known as the endpoints of this function, okay? Those are the endpoints. It's where the last values given by, the extreme values given by the domain are found in the graph, basically. Those are the endpoints of a function. Okay, so let's see this problem. Let me write that here for you to remember that. Endpoints, we can say that points A and D of the graph below are endpoints of the function. Okay. So, for example, 28, it says the following. Identify each labeled point as an absolute maximum or minimum, a relative maximum or minimum, or neither. Okay? So let me zoom here at this graph. This is what we have discussed in the previous live session. If we were to identify what each of the points represent, we can, for example, say that point A is neither, right? It's neither a maximum nor a minimum, because it's a point that is setting in the middle of this graph. Okay, so we say that point A is neither, right? Neither. Then what about point B? We see that point B is actually a relative maximum point, right? Because the function is increasing here and then it starts to decrease. And if we draw a tangent through point B, we would have a horizontal line which has slope 0. So all of the conditions are met for this point to be a relative maximum. But it is not an absolute maximum. Why? Because there's a point D which is above point B. So we cannot conclude that this point is an absolute maximum, but rather it's a relative maximum. Okay, so relative maximum point. Okay, then if we analyze a point C, we see that point C is a relative minimum, right? Because the function is decreasing here and then it starts increasing. And if we draw a tangent line through point C, we would have a horizontal line, right? So all of the conditions are met for point C to be a relative minimum. Now, is it also an absolute minimum? In this case, yes. Why? Because point C is at the lowest point of this graph as it is graphed in this exercise, right? So point C is an absolute absolute minimum. Absolute minimum. And we can write in parentheses that it's also a relative minimum, right? It's also a relative minimum, although the word absolute is already containing the implicit word relative minimum as well. Okay, finally, for point D, we're going to say that point D is not a relative maximum, right? Because the function is only increasing here, and we don't know what happens with the function later on, so we cannot conclude that it's a relative maximum. But we can conclude that point D is an absolute maximum, right? Absolute maximum, because it is at the highest point of this particular graph, right? So it's an absolute maximum. And it is, and let me write this in parentheses, this is not, so absolute maximum, and it is not a relative minimum, a relative maximum. Relative maximum. Why? Because it does not fulfill the condition in order to be a relative maximum. Okay, so I hope this concept of absolute and relative is clear for you. Now let's see part B. This was part A, and now we're going to see part B of the example. So it says, find the absolute maximum and minimum for this graph. F of x equals x squared minus 2x on this interval. So we're given an interval here a domain, which is from -1 to 2. So how do we find absolute maximum and minimum point for the graph? Well, we're going to follow the same process we have studied in the previous electronic assignment, in the previous video actually, the first part of this electronic assignment. And we know that in order to find maximum or minimum points, the first thing we need to do is find the derivative, the first derivative of the function. So we're going to find f prime of x. Let me copy a function first. F of x is equal to x squared minus 2x. So if we find the first derivative of this function, this would be 2x minus 2. In order to find maximum or minimum points, we need to set the first derivative to 0. This is a concept that you should already know. So from this, we're going to solve for x. We're going to get that 2 is equal to 2x. So x is equal to 1. This is a critical number. Now we need to determine whether this critical number corresponds to either a maximum or a minimum. To do that, we're going to apply the second derivative criteria. So we're going to find the second derivative of the function, which in this case would be the derivative of this, which is only 2. Okay, so we see that the second derivative is independent from x. It does not contain any x in its expression. So we say that it is always a positive value, independently of the value of x, right? So if it's always positive, that means that the function is being concave up, right? So let me write this. Always concave up. And if it is always concave up, that means that this critical number over here must be a relative minimum point, right? Why minimum? Because the function is being concave up. It is bended upwards the whole time. So this point over here, it's a relative minimum, right? Later on, we're going to see if it's an absolute minimum or it's just a relative minimum. But for now, we can only conclude that x equals 1 corresponds to a relative minimum. So we're going to write relative minimum. Then we're going to see what it actually is after finishing the whole analysis. Okay, so now in order to, we already have this information, but we need to, in order to finish determine whether this point corresponds to a relative or an absolute minimum, we need to evaluate our endpoints, okay? So if we evaluate our endpoints, let me write that, evaluate endpoints. Actually, before evaluating the endpoints, there's a step I'm missing here, which is finding the y-coordinate of this point. So to do that, we're going to replace x equals 1 into the original function, which is 1 squared minus 2 times 1. and this is equal to -1, right? -1. So we have the point which has coordinates 1, comma, -1. 1, comma, -1. And for now, we know that this is a relative. We're going to see if it's relative or not, minimum. But for now, it's a relative minimum. Okay, now we're going to do what I just told you, is to evaluate the endpoints of the function, which are this value and this value. So evaluate endpoints of f of x. In order to evaluate the endpoints of f of x, we need to replace into the original function, first of all, this value of x, and later on we're going to replace this value of x and see what values of y we get. So first of all, we're going to find f of -1, which is, so let me write that this and this are endpoints, just to make this clear. Endpoints. Okay, so f of -1 would be -1 squared minus 2 times -1. If we evaluate this, we get a value of, this is +3, right? 1 plus 2, yes, +3. So we get a point here which has coordinates -1, comma 3. And then if we evaluate the other value, f of the other endpoint was +2. So f of 2, this would be equal to 2 squared minus 2 times 2. And this is 4. 4 minus 4, that's 0. So the other point has coordinates 2, comma 0. Now, if we compare the 3 points we got, which are this, and this, we can finally see which one corresponds to an absolute minimum. We see that, for example, if we compare the y coordinates, this is -1, this is 3, and this is 0. So after comparing the 3, we can conclude that this point is actually an absolute minimum because it's the lowest value of y. Okay? So we're going to say that okay, so we already know that this is an absolute minimum, right? And what about the absolute maximum? We also need to find the absolute maximum. If we compare the 3 points, we see that the one that has the greatest y coordinate is the first endpoint, right, for -1. So this point, -1 and 3, corresponds to a absolute maximum. Okay, so that's exactly what we do to finish the exercise. So let me write that here. After comparing the three y coordinates, we conclude that. And what do we conclude? That the point, first of all, 1, -1 is the absolute minimum. There's no point which is below that point in this function. And that the point -1, 3 is the absolute maximum point. Okay, so that's all we need to do in order to determine absolute or general extrema. We need to, first of all, find the relative maximum minimum points, then evaluate the function for the endpoints, and then compare the y coordinates in order to finish concluding which one is the absolute maximum and which one is the absolute minimum. Okay, so I hope this was clear. Let's do another exercise where we're going to try to do this a little bit faster now that we already know the concept. It says, find the absolute maximum and minimum of the function on the given interval. So the same problem, but now we have a different function. So we're going to do the same thing. First of all, I'm going to copy the function. I'm going to see if I have enough space. Okay, so to save some space, I'll do the first derivative already. So f prime of x is equal to 3x squared minus, and this is 3x, right? The 2 simplifies. So that's the first derivative. Then we set this to 0 in order to find critical numbers. So If we take out a common factor of 3x here, we're going to get x minus 1. So one critical number would be if we set this to 0, and that occurs for x equals to 0. And then if we set this to 0, we're going to get the other critical number, which is x equals 1. Okay, so there we have two critical numbers in this case. Now, we're going to find the second derivative in order to see whether these critical numbers are minimum or maximum, relative minimum or maximum points, right? So the second derivative is 6x minus 3. If we evaluate the second derivative for both critical numbers, for the first one is f prime prime of 0, and this is 6 times 0 minus 3, and we get a negative number, which is negative 3. So this is a negative number. And if it's a negative number, then we know that for x equals 0, we should have a relative maximum, right? Relative maximum. There's a negative concavity. Okay, and then let's find the y-coordinate already for this point. So if we replace this into the original function, we're going to find f of 0. We're going to get that this is 0 cubed minus 3 over 2 times 0 squared, and this is equal to 0, right? So the point 0, comma 0 for now is a relative maximum point. We're gonna see if this is true later on. Okay, then we're gonna I need to evaluate the second derivative for the other critical number, which is x equals 1. So we're gonna find f prime prime of 1 and see what sign we get. We get 6 times 1 minus 3, and this is positive 3, so we get a positive value. That means that the critical number x equals 1 corresponds for now to a relative minimum point. Okay, so we're going to find the y-coordinate of this point by replacing it into the original function, f of 1. So this is 1 cubed minus 3 over 2 times 1 squared. And this is equal to 1 minus 1.5, that's negative 0.5, so negative 0.5. So the point, the point 1 comma negative 0.5 for now corresponds to a relative minimum. Okay, but we're still not done because we still need to evaluate the endpoints. So I'm gonna do a space here. So we're gonna evaluate endpoints. Evaluate endpoints. If we evaluate endpoints, first of all, I'm gonna mark these 2 points just to have them handy. We have these 2. Okay, so if we evaluate endpoints, for this particular exercise, the endpoint is from -1 to 2. So these two values, -1 and 2, are my endpoints. So let me write that here. -1 and 2 are my endpoints. So if I evaluate the function for the first endpoint, which is -1, we're going to get as a result -1 cubed minus 3 over 2 times -1 squared. If we solve for this, we should get a value of, this is -2.5. -2.5. That means that this point has coordinates -1 comma -2.5. Okay, so this is another point that later on we're going to compare. And if we evaluate the other endpoint, that's f of 2, we're going to get that this is 2 cubed minus 3 over 2 times 2 squared. And this would give us a value of 2, right? It's 8 minus 6. Yes, 8 minus 6, so that's 2. So the other point, let me write that just to avoid confusion. This is 8 minus... Wait. This is 8 minus 6 which is equal to 2. Okay, so this is f of 2. That means that the other point has coordinates 2, 2. 2, 2. So now we are going to compare the 4 points we calculated for this exercise, and we're going to conclude which one is absolute maximum and which one is absolute minimum. So after comparing y coordinates, after comparing y coordinates, we conclude that which one is, for example, the absolute minimum. We see that this has 0, negative 0.5, negative 2.5, and 2. So we see that the smallest value of y is this one, right? Negative 2.5. So the point negative 1, comma, negative 2.5 corresponds to an absolute minimum in this case, minimum. And if we compare the y coordinates again and we look for the greatest value is for this one over here. So that point corresponds to a absolute maximum, right? 2, 2 is our absolute maximum. So we can also confirm that these 2 points we calculated here are relative maximum and minimum points. They are not, neither of them are absolute maximum nor minimum points. Okay, so this would be our final answer after doing all of the comparison, and that's it. Okay, I hope this was clear. Next class we're gonna get into optimization, which is a very interesting topic. And okay, if you have any doubts, please let me know. Okay, have a nice day.